Hello friends, I hope you all are doing well. Today we will start with synchronization in Java part 2. In the last tutorial we have seen what is synchronization and what are the types of synchronization. One is mutually exclusive and the next is inter-thread communication. In mutually exclusive we have seen it is of three types: synchronization method, block and static synchronization. Today we will start with inter-thread communication. In case you want to see any of my previous tutorial, then I will give the link in description and you can refer that. Now let's start with inter-thread communication. Before inter-thread communication, we want to understand one concept, which is deadlock. What is deadlock in Java? Deadlock in Java is a part of multithreading. Deadlock can occur in a situation when a thread is waiting for the object lock that is required by another thread, and second thread is waiting for object lock that is required by first thread, which means thread 1 has occupied resource 1 and waiting for resource 2, but thread 2 has occupied resource 2 and waiting for resource 1. So both are waiting for one of the thread which is locked by another thread. So this is a continuous waiting condition. This is called deadlock. Let's see this. Here we have two variables, resource 1. We have another variable, resource 2. Now we have two threads. What they are doing is thread 1 is occupying resource 1. Now there is some delay in between so that we can understand. It requires try catch. Next, thread 1 is trying to occupy resource 2 now. This will work perfectly fine, but when we have another thread which is in reverse order, which means we have thread 2 which has occupied resource 2 in the beginning and then waiting for resource 1. Now when both thread will run parallelly, thread 1 will occupy resource 1 waiting for thread 2, but thread 2 has already occupied thread resource 2 and it is waiting for resource 1. So both have one of the resource and waiting for the other of the resource. This is deadlock. Let's run this. Now let's run this. Here you will see R1 is occupied by thread 1, R2 is occupied by thread 2. Now both other threads are waiting because they have the lock here. This is deadlock situation and the program is still running. I have to terminate it forcefully. This is deadlock condition. Now how to tackle the deadlock situation? Number one is to write a logic in a way that there should be no deadlock. Like here thread 1 is trying to have a lock on resource 1. Here also we can write take a lock on resource 1 then lock 2. Now when first thread will take the lock on resource 1 and when the second thread will try to have the lock on resource 1 but resource 1 is already logged by this, so this will not start till thread 1 is finished. This is one way. If I will write this, here see resource 1 is occupied by thread 1, then thread 1 will take resource 2 as well, then it will be finished. After this it will be finished, then resource 2 will be occupied by thread 1. I need to write R1 here. So resource 1 will be occupied by thread 2, and then resource 2 will be occupied by thread 2, and the program is finished. This is one of the solution, but the other solution to prevent deadlock is inter-thread communication. Inter-thread communication is to tell second thread by the first thread that the resource is logged. So this is communication. How threads communicate with each other? By using three methods: wait, notify, notify all. Wait method causes current thread to release the log and wait until either another thread invoke notify or notify all. It means if we will have wait method on one of the thread, then it will release the log and let method 2 start or proceed. Let's see the example on the bank transaction, like we want to deposit or withdraw some amount. Here, let's remove this. Let's have a class bank. In that there is some initial amount. Alright, let's take customer. We have some initial balance 10,000. Now a person wants to deposit some amount and withdraw some amount. Public void withdraw int balance. Now what will happen if the balance is not available here? If a person wants to withdraw 9,000, then it's fine. But if a person wants to withdraw more than the deposit amount, more than the 10,000, like 11,000, it should not be allowed, right? In this case, we will wait for the person to deposit some amount, then he can withdraw. So we will write if balance is less than initial balance, then what will happen? He cannot do anything. So he will only wait for someone to add the balance in his account. Wait should be with the synchronized method. It will tell you first have a try catch, and whenever you will use wait, the method should be synchronized. Indeed. Now what will happen when someone will call the notify, then the flow will go from here to the next step. Here we will reduce the balance. Initial balance equal to initial balance minus the balance that we want to withdraw. That's it. Now sys out success. Now I want to deposit the amount. Deposit means we will add this balance in the initial balance. Then sys out success. Now we will call notify. Notify means now, okay, I will tell you here. You have a object of class customer. Customer has initial balance of 10,000. You will create a thread. What it will do is it will deposit, sorry, it will withdraw some amount. It will withdraw 11,000. It should be surrounded with try catch. Now we have another thread which will deposit the balance. Let's say T2 deposit 2000 rupees. Now T2 dot start. Now what will happen? Once we will execute the program, flow will go here, T1 dot start, which means it will call withdraw. Flow will go here, it will try to withdraw the balance, but the balance is less than the initial balance, so it will wait for anyone to deposit. So it will release the lock here. Now next thread will execute, it will call deposit method. Deposit will add the balance and then call notify. Now initial balance will change to 12,000. As soon as notify is called, the wait will get the log again. Now the balance is 12,000. So we will remove this balance. It means we will withdraw the balance and then it's a success. Let's run this. Success, indeed. This is how synchronization works with inter-thread communication. Well, I hope you understood the session. Do like and subscribe for more updates and let me know in case you want a tutorial or any specific topic, then I will help you. Thank you.